This video is going to cover the 4.4 warm-up and then the 4-5 notes. So if you'll make sure that you've allowed time for the 4.4 warm-up to be completed, and then continue this video. All right, so 4.4 warm-up starts with, given that the cosine of theta is negative 5/13 and the sine of theta is greater than 0, find the following. So the first thing we can start to set up is our triangle. And we know that the cosine is the adjacent side over the opposite. Over the hypotenuse. So this would be 5 and this would be 13. I know the missing side is 12, but then I got to focus on my signs. Because this is negative and the radius is always positive, I know the 5 gets a negative, but then I need to use this piece of information to make sure that the 12 is also not negative. So because it says that the sign would be positive, if you look at the 12 and the 13, obviously that would stay positive. If this had said less than 0, then I would have known to make that 12 negative. But that's not the case. So I'm going to leave it positive, and then the sine of theta would be 12 over 13. And the cotangent of theta, which would be adjacent over opposite, would be negative 5 over 12. 3, 4, and 5 say to evaluate the trig function. So now this is more unit circle based. The tangent of 3 pi, remember that the whole numbers, evens are on the right, odds are on the left. So 3 pi would be over here. And my coordinate point would be negative 1, 0. And the tangent is y over x. So 0 over negative 1 would give you 0 as the tangent. The secant at negative 3 pi over 4. This time I'm going negative, so I would start at my standard angle, which is here. Negative 3 pi over 4 means I'm going past the 1/2 mark and midway through that third quadrant. So the over 4 here would have a coordinate point that's negative root 2 over 2 and negative root 2 over 2. And the secant is the reciprocal of cosine. So because cosine is x, I'm going to grab the x and I'm going to flip it, which would be 2 over negative root 2. Rationalize that. And I get 2 root 2 over 2 negative, which results in negative root 2. And then the sine of 13 pi over 6. So this one I'm going to, because it's bigger than 2 pi, convert into a mixed number. This is 2 and 1/6 pi. Evens are on the right, so I know I'd go all the way around my circle once and I'd end up over here. And then 1/6 past that means it's going to hit the first over 6. And that coordinate point is root 3 over 2 and 1/2. And the sine of that is the y, so this would be 1/2. Okay, so now we're going to get into notes for 4.5. This section is going to cover the graphs of the sine and the cosine. So while it's connected to what we were doing before, this is actually quite different from the unit circle and finding the trig functions around it and then the right triangles. Now we're talking about the curves that these would form. The first one we're going to talk about is sine. So the sine curve looks like this. This is one period of the sine curve. And where this comes from is that on the x-axis are the angles in degrees around your unit circle. And then on the y-axis, this is the coordinate point, which would be the y, because it's sine. So if you, actually, I'll pull in the unit circle so that we can compare these. If you were to look at the sine coordinate points moving around your circle, the first one here is at 0. So let's look at where the angle is 0, which is here, and look at the sine, which is the y, that's 0. So that's where this coordinate point comes from. Then I go to pi over 6, and pi over 6 would be here, and the coordinate point would be 1/2. That's where this coordinate point comes from. Pi over 3 would be root 3 over 2, and root 3 is like 1.4, so 1.4 over 2 is kind of like 0.7. That's where this one comes from. And then at pi over 2, my y is 1. That's where this comes from. So then if I continued to look at the y coordinates moving around my circle, each of them would align with the coordinate points that are on this curve. So this is how standard sine is formed. Okay, it starts at 0, 0, it goes up to 1, comes back down at pi at 0, goes down to negative 1 and comes back up to 2 pi. That's one complete period of the sine curve. Here's a picture with multiple. So that sine curve doesn't end. If you think about your unit circle, it's sickle. Like if you keep going around and around and around and around, it's going to continue around that pattern. So it forms this wave shape and it just continues without end in either direction. So for the most of the time, you're going to get asked to graph one cycle or one period of your function. If it does ask you to graph more than one, then you would just extend it in either direction, left or right, because it doesn't matter, in the same pattern that you were doing before. So this is where we start. The amplitude is how high and how low your graph's going to go. So if I start with my standard equation being y equals a times the sine of bx, then the amplitude, which is half the distance between the max and min values of the function, is given by the absolute value of a. So this tells you from 0 how high up your curve's going to go, and then back from 0 how low your curve's going to go, and that would be equidistant. The period is the horizontal distance of one complete cycle. So this is how long it takes you to get from the start to the finish of one curve. Notice in this one, it gives you, this is 2 pi over b, which is here. So amplitude is the absolute value of a, period is 2 pi over b. The a is what's on the front of the trig function. The b is what's in between the trig function and the x. Then from there, so the first thing we're going to do is identify the amplitude in the period. And then from there, we're going to find the values of the 5 key points. And to do that, we're going to take the period, whatever that period is, we're going to multiply it times a fourth, we're going to multiply it times a half, and we're going to multiply it times 3/4. And this gives you the 3 middle key points. So when you line them up, the first key point is 0 without a phase shift, which we'll talk about later. The second one comes from multiplying by a fourth. The third one from a half, third from 3/4, and then the last one is the period. So all together, you should have 5 key points on your axis. Then you're going to start at 0. You're going to go up your amplitude, down, down, back up again. So let's look at an example. This says graph y equals 2 sine of x. So the first thing we want to do is identify our a, which is 2. And that means our amplitude is 2 because it's the absolute value of 2, stays the same. The b, which is what's in between the sine and the x, is 1. And the period is 2 pi over b, which means it's 2 pi over 1, or 2 pi. Then I'm going to take 2 pi, and I'm going to multiply it times a fourth, times a half, and 3/4. 2 pi times a fourth, 2 pi times a half, and 2 pi times 3/4. So 2 goes into 4 twice. This is pi over 2. 2 is canceled. This is pi. 2 goes into 4 twice. This is 3 pi over 2. So these are the 3 middle key points. The first, because there's no phase shift, which we'll talk about later, is 0. And the last is the period, which is 2 pi. Now we're going to draw our curve. So my first key point is at 0. The next one is at pi over 2. Then pi. Then 3 pi over 2. Then 2 pi. And our amplitude, remember it's 2. So we're going up to 2, down to -2. And then the sine curve starts at 0, 0, goes up to the amplitude, comes back down to 0, down to the negative amplitude, and back up to 0. And then you just want to connect your points to make your curve. Example 2 says y equals 1/2 sine of x. I'm going to start the exact same way. I'm going to identify a. This time it's a half, which means that's my amplitude. B is what's in between the sine and the x, which again is 1. which means our period is 2 pi over b, or 2 pi. Since we already did this, we already know our points that are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now when I go to graph it, I'm going to mark the same horizontal points. 0, pi over 2, pi, 3 pi over 2, and 2 pi. But this time, my amplitude is 1/2. So I'm going to start at 0. I'm going to go up to the half mark, back down to 0, down to the negative half mark, back up to 0, and there's my curve. So the only thing that changed between example 1 and 2 was the amplitude. Now let's look at one more example. So this time our A is 3, which again is our amplitude. Our B is now 2. So the period is 2 pi over 2, which is pi. Now I'm going to multiply pi times 1/4 times 1/2 and 3/4, and I get pi over 4, pi over 2, 3 pi over 4. I start at 0, I end at pi, which is the period. I'm going to label my horizontal points, which are 0, pi over 4, pi over 2, 3 pi over 4, and pi. Now we're planning our own spacing here, so it doesn't really matter how wide you set that up. But if I had given you an actual coordinate grid where I had given you 0 and 2 pi, then you would need to know to cut this in half. So then my pi over 4, my pi over 2, my 3 pi over 4, and my pi would happen in a much more narrow space. But again, we're working at our own space, so I'm just going to plot it where it is. Now my vertical points are 3. So up 1, 2, 3, down 1, 2, -3. And again, this is still sine, so I plot it at 0, 0. I go up to the amplitude, which is 3, down to 0, down to -3, back up to 0, and I connect my curve. Okay, last example before we move on to cosine, sorry. So this is determine the amplitude and period of the following and then graph the function. So again, we're starting the same. A is 3, which is your amplitude. This time, B is actually pi. So my period is 2 pi over pi, which is 2. Notice this time that my key points are not going to have pi in them. That's fine. It's actually easier because I'm going to take 2, multiply it times 1/4, times 1/2, and times 3/4. So this becomes 1/2, 1, and 3 over 2. First point still at 0, last point still at the period, which is 2. Plot my horizontal, which are 0, 1/2, 1, 3/2, and 2. I'm going to go up 1, 2, 3 for my amplitude, down 1, 2, 3, -3 for the other part of the amplitude. And again, start at 0, up to 3, down to 0, -3, back up to 1, or back up to 0, and then connect your curve. So actually, before we go on to cosine curves, we're going to talk about what happens with a phase shift. So a phase shift is a horizontal shift. What happens when I take that curve and instead of starting at 0, I shift it to the right of 0 or to the left of 0. And a phase shift occurs if you've got something adding or subtracting to the x inside the parentheses. Just like every other graph, when we do something inside the parentheses, it shifts it left or right. So this is how your book actually recommends that you do it, is to figure out that your phase shift is C over B, and then shift it to the right or to the left once it's already graphed. So what we're going to do is we're going to solve for x in here, which is the same thing as finding out what C over B is, and that's going to be your phase shift. And then you are going to take your phase shift and you're going to add it on to your 5 key points. This means that you're no longer starting at 0. If it's positive, obviously, you're going to start to the right of 0, and all of your other key points will shift to the right. If your phase shift is negative, then it's going to shift it to the left. So everything would have started behind your y-axis. So let's look at an example that has a phase shift. Example 5 says, determine the amplitude, the period, and now phase shift of the following, and then graph the function. So we start the exact same way as we did before. We identify A, which is 2, and again, that's our amplitude. The B is still what's in between the sine curve and the x, which is now 4. So the period is 2 pi over 4, or pi over 2. Then I'm going to find my key points. So I'm going to do pi over 2 times 1/4, pi over 2 times 1/2, and pi over 2 times 3/4. And I get pi over 8, pi over 4, and 3 pi over 8. And again, remember the first one would be 0, and the last one would be the period, which is pi over 2. Now, what's different with the phase shift is first I'm going to figure out what my phase shift is. That negative C over B means negative pi over 4, or just take that 4x plus pi, set it equal to 0, and solve for x, and I get the same thing, negative pi over 4. So this is going to shift my entire curve left pi over 4. Again, it's left because this is positive. It's always the opposite, but also when we solve for the phase shift, it is negative, which means I'm going to then take that away from each of my 5 key points. So I'm going to go to my 0. I'm going to subtract negative pi over 4. From pi over 8, I'm going to subtract pi over 4. From pi over 4, I'm going to subtract pi over 4. 3 pi over 8. And pi over 2. So again, you've got negative pi over 4 here. You're going to have to change these denominators so they're the same. So this is 2 pi over 8, and I get negative pi over 8. This cancels, I get 0. Change these so they're the same denominator, 2 pi over 8 again, and I get pi over 8. And then change this. So it's 2 pi over 4 minus pi over 4, and I get pi over 4. So those now are your 5 key points. And you want to look at them before you set up your graph, because notice that there's 2 that are negative. So when I draw my graph, I want to make sure I have enough space so that I have room for my key points both on the left and the right of this curve. Okay, so now I'm going to mark my key points. I'm going to start at negative pi over 4, negative pi over 8, 0, pi over 8, pi over 4. My amplitude is 2, so I'm going up to positive 2 and down to negative 2. And now my 0 starts here. I start at 0, I go up to the amplitude, down to 0, down to the negative amplitude, and back up to 0. And there's your sine curve with a phase shift. Okay, let's try one more. Again, same set of directions. Again, same beginning steps. I'm going to start by identifying A is 1/2. B is now 2, which means the period is 2 pi over 2, which is pi. And I have a phase shift. So if I solve this, I get 2x equals pi over 2, divide by 2 or multiply by 1/2, and my phase shift is pi over 4. Now it's a positive, which means I'm shifting everything to the right. So I'm going to take my period, multiply it times 1/4, and I get pi over 4 times 1/2, pi over 2, 3 pi over 4, and I get, or pi over 3/4, and I get 3 pi over 4. And then the last one is the period, and the first one is 0. And now I'm adding my phase shift. And I get pi over 4, 2 pi over 4, which is pi over 2. This multiplied by 2, so this is 2 pi over 4. That's 3 pi over 4. This is 4 pi over 4, which is pi. And this 4 pi over 4 plus pi over 4 is 5 pi over 4. And now my key points are pi over 4, pi over 2, 3 pi over 4, pi, and 5 pi over 4. They're all positive, so when I set up my graph, I just want to make sure I have enough room to the right now to plot all my key points. So first one being pi over 4, then pi over 2, then 3 pi over 4, pi, and the last one, 5 pi over 4. Amplitude this time was 1/2. So if this is 1, I'm only going to go up halfway. I start at 0, I go up halfway, come back down to 0, negative 1/2, and back up to 0. And there's my sine curve with a phase shift and an amplitude of 1/2 and a period of pi. Okay, so now what happens when it's cosine? The good news is everything procedure-wise is exactly the same. The steps are exactly the same. We find A, amplitude, B, period. The 5 key points, if there's a phase shift, we adjust it. All of that is exactly the same. The difference between sine and cosine is the shape of the curve. So again, if I bring in the unit circle and we look this time at the cosines as you move around, you'll see that at 0, your cosine, which is your x value, is actually 1, which is up here. At pi over 2, your cosine is 0, which comes down here. At pi, it's back to 1, or negative 1, which is why it's here. At 3 pi over 2, back to 0, and back up to 2 pi, it's up to 1. So now my curve starts up at 1, or what will be the amplitude, comes down, passes through, goes to the negative amplitude, and then comes back up and finishes at the amplitude. So that's one period of cosine. Starts up, comes down, down, up, up. Kind of shaped like a U or a V. Okay, so this one, I'm actually going to have you change it so that it's positive first, and then we'll talk about what happens if it's negative, since we haven't done a negative one. So A is 2, which is your amplitude. B is 4, which means the period is 2 pi over 4, or pi over 2. There's no phase shift, so I'm just going to take that pi over 2, multiply it times 1/4, times 1/2, and times 3/4. And I get pi over 8, pi over 4, 3 pi over 8. First one is 0. Last one is the period, which is pi over 2. Then comes my graph. Plot your key points. 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. And the amplitude is 2. So up 2, down 2. So remember that this time, when we do our amplitude, we have to make sure that because it's cosine, we have to start at the amplitude instead of at 0. So I'm going to start up here at 2. I'm going to go down to 0, down to -2, up to 0, and then back up to +2. And there's your cosine curve. So now what we changed on this was making that positive instead of negative. The negative on the front of a graph with cosine and sine have the same effect as everywhere else. It's a reflection over the y-axis. So basically what happens is the pattern changes. If I put the negative back on here and that says negative, instead of starting at +2, I actually start down here at -2. I come up, up, down, down. So it flips it upside down and it would look like that. So if that negative, let's say, was on a sine curve, let's say I had y equals negative sine of x, then I would have plotted my 5 key points. And instead of starting at 0 and going up to the amplitude, I would start at 0 and go down to the amplitude, up, up, down. So the pattern reverses vertically. If it's a negative cosine, I start at the negative amplitude and go up, up, down, down. If it's a negative sine, I start at 0, go down to the negative amplitude, and then come back up and down. Okay, so now I've got a cosine with a phase shift. Start the same way. A is 2, which is your amplitude. B is 3. Period is 2 pi over 3. And there's a phase shift, so if I set this equal to 0, I get 3x equals pi, and x equals pi over 3. And that's my phase shift. So I'm going to take my period, 2 pi over 3, multiply it times 1/4, times 1/2, and times 3/4. So 2 cancels here, I get pi over 6. Here I get pi over 3. Here I get pi over 2. Again, first one's at 0, last one's at 2 pi over 3, or the period. Now my phase shift is +3. 4, 5 are my key points. They're all positive, so again, I want to set up my curve so I make sure I have room to the right. So this is pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. Amplitude is 2, and this is cosine. So I'm starting at the amplitude, which is 2. I come down to 0, down to -1, up to 0, up to positive amplitude, which is 2. So probably the biggest mistake people make with the cosine and the phase shift is starting this point over here on the y-axis. Remember that it's a phase shift, so you want to shift it to the right, and that's your beginning point. Okay, last kind of shift we're going to talk about is the vertical shift. So again, just like every other graph we've talked about up to this point, if we add or subtract a number on the front or on the back, because this could also say 2 plus sine of x. If it's separated by a plus or minus sign, then it's going to be a vertical shift. So these are super easy. You're going to do everything we did already. We're going to plot our curve, and at the very end, we are going to shift them up or down. Okay, so this one says determine the amplitude in the period of y equals -2 cosine of 4x plus 1. But we're actually going to continue and actually graph it. So now A is -2, which means the amplitude is 2, but we're going to flip it upside down at the end. The B is 4, so the period is 2 pi over 4, or pi over 2. No phase shift, but there is a vertical shift this time, and it's up 1. So pi over 2 times 1/4 times 1/2 times 3/4, and I get pi over 8, pi over 4, 3 pi over 8. First one's at 0, last one's at the pi over 2, or the period. Then comes the graph. So 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. Amplitude is 2. But it's negative. So instead of starting, it's cosine, right? So instead of starting at 2, going down, down, up, up, I'm going to start at negative 2, go up, up, down, down. And then I'm going to shift everything up one place. So this shifts up 1, up 1, up 1, up 1, and up 1. And that is your final curve. So you can either draw both and like dash out your initial curve, or you can erase it, or you can, use it darker, or you can try to flip it in your mind, but just be really careful with these. The most important thing with the vertical shift is that you make sure that you flip it before you do the vertical shift. That's if you've got the reflection and the vertical shift. You want to flip it before you do that vertical shift. Okay, last one. Determine the amplitude, period, and phase shift. This time we'll just do the amplitude, period, and phase shift. We won't graph it. The A is 2, which is your amplitude. The B is 3, so your period is 2 pi over 3. And there's no phase shift, but there is a vertical shift down 1. So I would take my curve. Again, this is cosine, so it would have some sort of shape like this. And I would shift everything down one place. So because the amplitude was 2, this would shift down, this would shift down, down, up, up. So your curve would look something like that. And last question is good news calculator. So this says you're riding a Ferris wheel. Your height, age, in feet above the ground at any time t in seconds can be modeled by h equals 25 sine pi over 15 times t minus 75 plus 30. And it says the Ferris wheel turns 135 seconds before it stops to let the first passenger off. Use the graphing utility to graph the model. What are the minimum and maximum heights above the ground? So I'm going to type this into my graphing calculator. So the first thing is when you're typing this into your calculator, be really careful where you place your parentheses. You want it to find the sine of this whole part. So you want to make sure that you put double parentheses around your pi over 15, and then again at the end where it's like x minus 75 and the variable, so you can use the x. And it should look something like this. And then when you pull in the actual graph, you get something that looks like this. So I had a pinch and zoom so I could catch the whole curve. You'll want to do the same thing. But what it says is what are the minimum and maximum heights above the ground? So you could actually think about just your model here and what's happening. 25 is your amplitude, which is how high it should go. But you also have a vertical shift of 30. So when you look at your graph, I mean, obviously you can just hit max and see what it is. But it should make sense that this is 55 here because we went up 25 for my amplitude, but then we shifted it up 30. So the maximum there is 55. And then the minimum on any of these, because they're the same, is 5. And that's because we would have gone all the way down to negative 25 for our amplitude, but then we added the 30 to it to bump it up vertically, and so that makes sense that would be 5. So you will see word problems where you've got applications of the sine and cosine curve, and you want to just graph it. If it says use graphing utility, graph it, include it in your homework, and then just answer the questions based on it. So your homework, you hopefully have already noticed, for 4.5 is not on WebAssign because it's so important that you graph these by hand, okay? There's a PDF of them. But note that I will be looking for the work for the key points. So don't graph these by a graphing utility. You have to show the work for the graphs. You have to show the graphs in order to get the full credit. I know that was a long video, and good job listening all the way through it. Obviously, we'll review 4 or 5 on Monday with the on Tuesday with the warm-up. Enjoy your long weekend, and I will see you Tuesday.